Variation of the boiling temperature of a liquid with pressure. Latent heat of vaporization. These are the goals and the physical foundation behind the experiment. We are going to study one-component systems, in particular the boiling temperature of one component at constant volume. Therefore, we aim to draw pressure versus temperature curves by experimentally determining the temperature of this one-component system at different values of pressure. If we take a different component, we'll move on a different PT curve. In both cases, these curves separate the liquid and vapor phases. On the line, both phases coexist. In other words, they are in equilibrium. The liquid-vapor equilibrium for unary systems is governed by the Clausius-Clapeyron equation. In order to solve it, we assume that, first, the volume of the vapor phase is much higher than that of the liquid phase. Therefore, the latter can be neglected. Secondly, the vapor phase can be described by the equation state of ideal gases, PV equal to RT. As a result, the equation can be simplified as follows. If the variables are arranged so that pressure stays on one side of the equation and the temperature on the other side, and we assume that the latent heat of vaporization can be regarded constant, we can then simply integrate between initial and final states. We thus get an expression for our experimental data that relates the Neperian logarithm of pressure with the inverse of temperature. The relation is linear and the slope of the line is exactly minus the latent heat of vaporization divided by R. Therefore, we immediately obtain the latent heat of vaporization for the considered component. The experimental setup is shown here. Recall that the liquid is placed inside the glass flask and can be conveniently heated with a round bottom flask heater. We first pump the system to lower the pressure. And the display shows continuously the values of pressure and temperature inside the flask. Notice how the pressure is decreasing upon pumping. The value of atmospheric pressure is shown at the center of the screen for your guidance. If we then heat the liquid inside the flask till it boils, and we let the system stabilize so that the temperature does not vary, the pressure can be varied on demand. To do so, we can use the stopcock valve to change the pressure inside the flask. The display will then show us in situ the new values of pressure and temperature. The experiment can be repeated as many times by changing the value of pressure through the stopcock valve.